Come on. That was fantastic. Did you not see that? I said good luck, and then I flipped my bottle, and it landed. That really? Like nothing?
It's not too much to flip a bottle. Third try.
Come on up then. Come on, Sarah. It's not that hard, Sarah. Let's go.
Oh.
You would have been impressed, right? Like if I was looking like just like doing the side eye thing. Yeah, I've missed. Okay. So anyway, it was good luck. Carson saw it.
You're 1 for 4.
Hey, Sarah. I love you guys dearly, but we're like family. You know how sometimes you always love your family. Doesn't mean you always have to like them. Right now,
Yeah.
that's where we're at.
Yeah. I've been there for a while.
Hey! 1 for 1.
Okay.
1 for 1.
Sure.
No, it starts over every time.
Okay, yeah.
Yeah, 1 for 1. Okay, listen.
That's what we'll say.
You have 2 ways to find your x-intercepts. You always have 2 ways to find your x-intercepts. We can try to factor, which is fine. You could also use the quadratic formula, which is fine. My guess is, I'm hoping most of you did the factoring. You factored?
I did both. I tried.
Did both of them work? They got the same answers for you?
No, I messed up on one.
Okay. So you guys factored or use the quadratic formula?
Yeah, quadratic.
Quadratic? Okay.
I'm pretty sure.
So let's go with our quadratic formula then. Since most of us did that. So we're going to come down. We're going to say A equals B equals C equals. From here, I've got -6, I've got 10, and I've got 4. Everybody with me there? Okay. If I factor, I'm going to try to do both very quickly. I'm going to factor out my -2. So now I have -2 times 3x squared minus 5x minus 2, which is -2x, times 3x plus x minus 2 and 1. Okay, so somewhere, for some reason, when we do the quadratic formula, we are not getting the same x-intercepts. And I'm not quite sure why, so we're going to figure this out. Okay, so factoring wise, we come here, we say -2 equals 0, 3x plus 1 equals 0, x minus 2 equals 0. So we should have our x-intercepts being x equals -1/3 and x equals 2. My guess is when you did the quadratic formula, that's not what we got.
I got that.
You did get that? Okay, so then we need to figure out what you did wrong, okay? So we have our x-intercepts here. And the reason why I wanted to check this was to make sure because Cordell has a little error going on, and we're going to figure out why. So there's my x-intercepts by factoring. Factoring is not too hard, correct? Okay, I'm going to erase that. Most of us probably on the video factored, it's there. We need our x-intercepts in order to find that line of symmetry, in order to find the vertex. So let's try again. So I've got my A, B, and C. We know x is equal to the opposite of b, -b, plus or minus the square root of b squared minus 4 times A times C. Does everybody agree with this so far? All divided by 2A. Yes? Okay. So now we've got x equals, and I'm going to, actually let me do it over here. X equals -10 plus or minus the square root of 100 plus -4 times -6 is 24. 24 times 4 is?
We forgot the square root.
No, I didn't forget anything.
I did.
You forgot the square root. Okay.
See.
Good. So that gives me 96. Is that correct?
Yeah.
Check my math. Sometimes I'm good at it. Sometimes it's been a long day. It's the afternoon, and I've only had 2 cups of coffee. Okay, x equals. So now we've got -10 plus or minus the square root of 196 divided by -12. X equals -10 plus or minus, I hope that's 14 divided by -12. Am I right? Square root of 196? Yay! Love when I'm right. So this is where we're going to break it apart. I'm going to break it apart down here. -10 plus 14 divided by -12. x equals negative 10 minus 14 divided by negative 12. We already know that we're going to get negative 1/3 comma 0. Nope, this one is positive. No, this is negative. Yeah, negative 1/3, right?
Yep.
Mm-hmm.
And this one's negative 24 divided by 12 is positive 2. Okay, so either way, whether we factor or whether we do the quadratic formula, we get the same x-intercepts. Everybody with me there? So now I'm going to come over here, I'm going to start to graph. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, on my graph, is it going to look perfect? Absolutely not. So we're over here at negative 1/3, and we're over here at positive 2 comma 0. We know our line of symmetry is somewhere in the middle. Well, how do we do that? We're going to add negative 1/3 plus 2 and divide it by 2, which leaves me with, and this is why I brought the handy dandy calculator. You guys forgot to tell me to tuck in my shirt. Now I look like a slob. 1/3 plus, so negative 1 divided by 3 in parentheses plus 2 divided by 2, math, enter, enter, gives me 5/6, or 0.83 if we wanted to give me my 8300ths. So we know our line of symmetry is somewhere around here. Now we're going back to our factored form. But wait a minute, when we do the quadratic formula, we don't have a factored form. So we're looking for f of x, which is our y. So now I'm going to say, okay, we don't know what this is, equals negative 6 times. And I'm just going to round, plus 10 times plus 4. And now I'm going to put in my calculator. Negative 6 times 0.83 squared plus 10 times 8300ths plus 4. And I get my f of x now equals 8 and 1700ths. So now I have a vertex of 8300ths, comma 8 and 1700ths. And the vertex is one of the most important things that we have. Give me moose antlers if we got that one. you just wanted to do moose antlers. That's fair, okay. Strange, but fair. Is anybody lost on what I've done? Okay. So now I'm over here at 87 or 8300ths, up 1, 2, 3, 4, 5, 6, 7, 8, and a little bit. Now I've got my vertex. Now, we should already be able to tell that this graph is opening down. There was something try again. So I was going to say originally, but I didn't like that. There was something immediately from the original equation that should have set our spidey senses off as to why that graph opened down. What up here told us that that graph had to be opening down? Carter?
The leading coefficient was negative.
Perfect. Thank you for using that great word. The leading coefficient was negative. When that leading coefficient is negative, it will always inverse the parabola. Okay? So now we need to find the last two things, which is my y-intercepts, which means my x is 0. So now I've got f of x, where negative 6 times 0 squared plus 10 times 0 plus 4.
Staff, could we please have you release the track team at this time?
Thanks for letting me know, Carter. Carter, you have your homework done?
Yeah.
Show it to me the next day. You do have homework. You're going to need these notes. Okay, so get with somebody and get the notes. Yes, sir? Okay. Or you can go to my YouTube page and this will be on there, so you can watch the rest of the video. Okay, so you don't really need a calculator here, because anything times 0, 0, plus anything times 0, 0. So 0 plus 0 plus 4 gives me my f of x of 4. So now my y-intercept is 0, 4. Everybody still with me? Mm-hmm. Point of reflection, if it's 8300ths over, it's got to be another 83, so I'm adding 8300ths plus another 8300ths, gives me 1 and 6600ths, which is somewhere like here. And now I can make my parabola. Have a good meet. You running the mile today? Mm-hmm. Okay, sub 6. Right? Yeah. Okay. Questions, concerns, problemos? Get your homework out. Let's see work for 1, 2, 3, and 4. Excellent. And then 7 and 8 is just pretty easy with real solutions. Now I should have no doubt that everybody did this. You guys had ample time to ask for questions during class the last time because you know I don't believe in actual homework. But look, your parents don't teach you. I do. Whether I teach you well or not, that's. Okay. Beautiful. Let's take a look. Perfect. Oh, it would help if I actually plugged it in, right? Got all this technology all set up. I was ready to. That bottle lucky flip was worthless. I blame Sarah. No, Sarah. Shut up, Nikki. Nikki, don't. No, you stabbed somebody with a pencil and.
2 out of 10.
Okay. I'm gonna throw this water at you guys soon. Just like spray it everywhere. Here we go, number 1. So you're just using the discriminant, that b squared minus 4ac to check. If it's positive, there's 2 real solutions. If it's 0, there's only 1 real solution. If it's negative, then there's no real solutions. Because when you take the square root of that negative number, it gives you an imaginary number. You're going to learn more about that in Algebra 2 in a couple years. Where's my mouse? There it is. Hi. Hey, Dad. Number 4, 2 real solutions once again. Questions on 1 through 4. 5, 1 solution, 2 or 6, no solutions. 7, 2, and 8 should be 1, I believe. Yeah, let me memorize these. Questions, concerns, problems? Wunderbar. I said wunderbar. Don't, Carter. At this point, after 2 years, what would make you think anything but me being weird? Like, really, after 2 years, you should have known that I was weird after, like...
I mean, I knew you were weird. I was just, like, pointing it out.
Oh, you just wanted to make sure
Yeah.
that
I
Hey, first off,
clarified.
really? You're going to come in and be like, Mr. H, it's your birthday. Happy birthday. Like, you're like a Sour Patch Kid. First you're sweet and then you're sour. Like, come
At
on.
least I told you happy birthday.
You did, and I appreciate that.
I was the first one to say it, too.
Well, actually, some of my other kids
Okay.
before you. But you were today. First off, in the afternoon, you're the only person in the afternoon.
Woo!
Woohoo! Well,
Yeah,
everybody
Mr.
go.
Beatty.
No,
Technically, I said it first. You said Mr. Beatty said
Sorry,
that.
who pointed it out?
You did.
Me.
Nope, Sarah wins.
Yeah.
But I said it.
Y'all are
Six.
just jealous.
I'm not jealous of
I
anybody.
wasn't talking to you.
Oh, for you. First off, you should never talk to me. Ever. Here we go. Okay, so this is a little different. This is called Vertex Formula. Now, I know we're going to go out on a limb here. Let's go back to slope-intercept form. I know. Yeah.
Y equals mx
Oh my
plus
gosh.
b.
Okay, thanks, Carson. Slope-intercept form was, Carson,
Y equals mx plus b.
y equals mx plus b. What were we guaranteed to know if something was in slope-intercept form? What 2 things?
I thought you weren't supposed to talk anymore.
Oh,
The slope.
the slope and
The Y-intercept.
the y-intercept. Hence the name slope-intercept form. If this is vertex form, what do you think we're guaranteed to know from vertex form?
It has a vertex.
Yes, Sarah. It has a vertex. We're... Oh my gosh. I hope that parents watch this and like, what actually happens in your class? Magic. Magic happens in the class.
Really off day. I cut myself this morning.
I'm sorry. So you're able to find the vertex, okay? So here's what we need to understand. The quadratic, the most basic quadratic, the parent function of the quadratic is y equals x squared. Okay, if you want to copy this down, great. If not, I've actually already shown you the parent function before. So what this means is we know that the vertex is at 0, 0. I know that if I substitute in 0, I get 0. If I substitute in 1, I get 1. Same idea with its reflection point, -1, +1. If I do 2, I get 4. If I substitute in -2, I get 4. So when I would graph this, and again, this is called the parent function, I would have my quadratic. 1, 1, then 2, 4. This is what every quadratic is based off of. Vertex form is saying, okay, we know the parent function. If we know the parent function, how can we get the door? Thank you. Second video, thanks. I'll close the door, don't worry. Thanks, man. All right. Whatever. Oh, lucky water bottle, you stunk it up. Okay, so if we know the parent function, what this is saying is, how can we transform that? How do we shift it? How do we make it bigger? How do we make it smaller? So a couple things that we're going to talk about today is stretching the function. So what I want you to do is, first off, pretend that you're holding a ball at the top and the bottom. You're going to need both hands, right? No, I really want you to do this, Sarah. Don't. Yep, you're going to pretend. There you go. Good. You're holding the ball. What would you do with your hands if you're holding on to the ball, like you're squeezing the crud out of it? How would you stretch the ball? What would you do to stretch it? You'd
pull it.
Yeah, you'd pull it, right? What would happen if I stretched this ball?
Break.
Yes, it would break. What else? Would it stay the same shape?
No.
No, what would it do?
Turn into an oval.
Yeah, turn into an oval and be very skinny, right? The same idea happens when we have a vertical stretch in vertex form. So one of the transformations is called a vertical stretch. So instead of having this nice, neat U, it's now almost vertical. This is a vertical stretch, okay? I've stretched it. It's become very skinny and very upright. Everybody with me? So that's one of the transformations. The other transformation is a compression. Yeah, which means, like Carter just did, we're going to push this ball down, so now it flattens out and becomes long, right? It becomes like a pancake. Same idea. So if I transform my parent function by compressing it vertically from top to bottom, now it's a nice wide U. Everybody with me? Mm-hmm. So those are going to be the first things that we're dealing with of vertical stretch and a vertical compression. But I want you to understand what the compression and the stretch actually were. So this A is for the vertical stretch or compression. That value is what tells me whether that graph is stretching and being nice and tight and very high, or whether it's really wide. So how do we know that? Well, it's a stretch if A is greater than 1. Now, there's going to be a caveat here, because I'm not talking about negatives yet. Okay? I'm not talking about negatives yet. So if A is greater than 1, so if this value is 1.5, 3 halves, 7/4, 27, man, that thing's going to be stretched, stretched, stretched. The bigger the A value gets, the more vertically stretched it is. Still with me? Okay. It's compressed if 0 is less than A, which means A is greater than 0, but less than 1. Which means it's a fraction that's not a improper fraction. Okay, 1/3, 1/50th. The smaller that number is, the closer to 0 is, the more compressed, the wider it's going to be. Okay? Now my question is, why don't I have a negative? Why am I not talking about the negatives? And we already talked about this. What does the negative tell us about the graph when it's that leading coefficient?
It'll be.
Go ahead, what?
It'll be. Right, it down.
Yeah, it'll open up down. So if it's greater than 1 on the negative side, which means it's less than 1, so -2, -3, -150, all that means is it's still going to be stretched vertically, but now it opens down. The negative, all it does is take that parabola from opening up to opening down. You've heard me say, hey, it's either a U or an umbrella. It takes that U and makes it an umbrella, right? Okay, that's all the negative does. So this is vertically stretching. That's one of our transformations. The other transformation is based off of the vertex. And this is the key to vertex form. The first thing that I want you to understand is this sign here. No matter what that sign is, means the opposite of. So once we start writing some of these, that sign means the opposite of. Right now, this says the opposite of negative h. What's the opposite of that negative h?
Positive H.
Positive h. The vertex is h, comma, k, where the h moves the vertex left and right. And you might be saying, Mr. H, what do you mean it's moving it left and right? It's moving the parent function. We're talking about that y equals x squared, where the vertex was at 0, 0. So if we're starting at 0, 0, that's moving it left or right on the x-axis. Okay? And I know that you're going to get this one because you guys are smart kiddos. What's the k going to do then? Yeah, say it again, Cordell.
Move it up or down.
Move it up or down. And this is all based off of, again, the parent function of y equals x squared, which means it's starting at 0, 0. So if my vertex is 4, 5, I'm going from 0, 0, I'm going right 4, up 5. So we've got several different translations or transformations. We've got a stretch and a compression, and then we've actually got the translation of how it's moving that graph. There's another that we'll learn eventually if we do something with the division of the x, but that's in Algebra 2. I'm going to save that for your Algebra 2 teachers. Okay? Everybody with me? Everybody has this stuff written down because you're going to need this. This is going to be on your quiz. Whatever day that is, next week. Next week?
It's next week.
Next Friday. Okay.
Next Friday. One.
Hi, Andrew. Oh, go back. Without graphing, what is the vertex? That's pretty much all I'm looking for from this lesson. So taking a look at A, bounce some ideas off each other, scream across the room if you got to. There's only a couple of you in here. Figure out what you think and why you have that answer. So what is the vertex for letter A?
Is it 5,3?
That's what I got.
So what'd you get?
5,3.
Absolutely. Because why, Cordell?
You do the opposite of the H's sign.
Yep.
And then you put K in.
Perfect. The opposite of what -5 is, which is +5, 3. Beautiful. A little bit trickier. Letter B. You're doing all of them, but now on B. No. Oh, you're talking to them. I thought you were shouting it to me. Go, Carter. Go, Carter.
-2.5.
What did you think it was?
0 and -2.5.
Okay.
You better explain why, Carter. Because I can see confusion up here. You can't see their faces, but I can see confusion.
Because there's no number after the x that would be in parentheses. So it
Okay.
would be
Yeah. But no, I had to process what he said.
So I'm going to kind of clean up what he said. If you couldn't hear it, he said, hey, the vertex is 0, comma, -2.5. I absolutely agree. But let's break this down for the y. I could absolutely write x minus h squared minus 2 5/10. But he's saying it's 0. Remember, x is still a number. It's part of that ordered pair on that graph. Let's say it was 7. 7 minus 0 leaves me with that 7. Let's say it's 1,000. 1,000 minus 0 leaves me with that 1,000. So all they did was simplify x minus 0 to leave them with that x squared. So if there's nothing in parentheses with that x squared, like Carter said, that means that that vertex is somewhere on the y-axis. Everybody with me? Last but not least, letter C.
I think it's 4, 0.
Yeah.
Got -4.
Wait.
Oh, yeah. It's -4, 0.
So redeem yourself, Carson. Why is it -4?
Because it's the opposite of whatever the sign is.
Yeah, it's the opposite of whatever that sign is inside those parentheses. Has to be the opposite of whatever that sign is. Therefore, it's -4. There's no plus or minus out there. You can always add a 0 to anything. Questions on that? Okay. You see questions like this on your quiz. Most of you have already dropped one. Well, not in this class. Some of you have already dropped one quiz. Okay, so you need to keep that in mind getting ready for this one. Most of you have already dropped a quiz, so you need to keep that in mind because you got to get ready for this one. Okay, number 2, A, B, and C. So we're now writing the equation. The problem that I have with this particular set of questions from Engage in New York is they're giving me the vertex, but they're not telling me if there's anything vertically stretched or vertically compressed. So for me, here's what I want to see on yours. I want you to have y equals a on all of them. Okay, whatever, we don't know what a is, but we're going to leave it there. I want you to get into the habit of saying, hey, there might be something there that's going to tell me. If it said there's a vertical stretch of 3, then I would know it's 3 times whatever I'm putting in that parentheses. Everybody with me? Okay. So, Nicolette, tell me what I'm doing.
Y equals a.
So far, so good.
Y equals a, parentheses, x minus 1 and 9/10, and then that's squared. And then minus 4.
Beautiful. So I've got a times the quantity of x minus 1 and 9/10 squared minus 4. Hard? Yep. B. Who thinks they can do B? Sarah, I haven't called on you. Think you can do B?
Y equals a, parentheses, x squared plus 100.
Perfect. So I'm going to get rid of the parentheses, only because we don't need it. Ax squared is fine. That leading coefficients always are a. Right? We know that from the quadratic formula. We know the leading coefficient is what tells me whether that graph is opening up or opening down. Plain and simple. Letter C. I'll take it. Y equals a, parentheses, x plus 2 squared plus 3/2. Again, it has to be the opposite of that h value. Questions, concerns, problems? Relatively easy. So far, there are 3 things that we're going to majorly touch upon on this quiz. You've got the quadratic formula. You need to know the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac. All of that's divided by 2a. Got to know it. You're going to need to know the discriminant. B squared minus 4ac. You're going to need to know vertex form. You might not need to write out y equals a times x minus h squared plus k, but you better know where everything's going to go. Everybody with me? You're doing the entire problem set, numbers 1, 2, and 3. You have approximately 7 minutes. There's no reasons not to get this done, but make sure number 3 has nice, solid sentences. It's asking a lot of you, so do it.